Hello and welcome to the Pre-Calculus Unit 2, Section 2 notes. This is a section over quadratic functions. This is a very important concept. We'll kind of talk a lot about through the remainder of the year. Our objectives today, we want to find the line of symmetry in vertex of a parabola given its function rule. We want to identify a quadratic function from the function rule and use key attributes of a quadratic function to solve word problems. So the first thing I want to do is just kind of talk about what a quadratic function is. A quadratic function is a function whose largest exponent is 2, okay? So the largest exponent is 2. All right, and that kind of tells us what we have. If you see a function like that and you see that you have a exponent of 2, you know it's quadratic, okay? A quadratic function, the graph is a parabola. And so, and that's something that, we'll talk about quite a bit. And so then the other thing is that when we have a quadratic function in standard form, you have this notation where it says f of x is equal to ax squared plus bx plus c, where a, b, and c are real constants, and a cannot equal 0. Okay, so we'll be able to identify what those values are. I'm going to write this out quite a bit and go through that. So the first question is select all the following that are quadratic functions. So, what we have here, what we're looking for is an exponent of 2. Okay, if we're looking for a quadratic function, we're looking for something with an exponent of 2. Exponent of 2. Okay, and so what we see here is even though this is x equals 3y squared minus 6y plus 5, okay, you could consider this a function x in terms of y, where you kind of like switch the x and y values. But because our largest exponent is 2, we're going to go ahead and call this a quadratic function. Okay, so we'll circle that one. The other one here, it says y plus 3 is equal to negative 2x squared plus 5. Again, my largest exponent here is an exponent of 2. So I'm going to go ahead and circle that one as well. This next one, y equals 2x squared minus 8x plus 6. We have an exponent, largest exponent of 2, so I'm going to go ahead and call that a quadratic function as well. Over here, y equals negative 7x minus 4. This would not be, because our largest exponent is 1. Okay, so this would not be a quadratic, so no. On the next one down, y minus 3x is equal to 4x cubed minus x squared plus 9. This 4x cubed, because my exponent is a 3, this is not a quadratic. This is something else, so no. All right. On this next one, y equals 5x times the quantity x plus 9 is, because if you were to multiply out the 5x and the x, you would get y equals 5x squared plus 45x minus 8, okay, because we have a large exponent of 2, then yes, this is a quadratic, okay. Over here on the bottom one, it kind of looks like it is, but what I want to do is go ahead and add 2x squared to both sides. So add 2x squared, these cancel out, and these also cancel out, so you would end up getting y equals 3x plus 4, which is a linear function, so no, okay. So we are looking for something with an exponent of 2, okay, bottom line. All right, we have some vocabulary that we need to go through. The first thing we have is a parabola, okay? It is the U-shaped graph of a quadratic function. And it is the set of points that is equidistant from a given point and a given line. And we'll kind of talk about what that means. The next thing I want to talk about is a minimum, okay? A minimum in a function, the y-coordinate. That is important that we stress that the y-coordinate is mentioned here because the minimum value is a y value. And I'm going to write that down here, okay? That the min value is a y value. Okay? And so it says that it's the y-coordinate of the lowest point on the graph of the function or smallest value in the range. So, you know, what I want to do is you just kind of want to think about like either like a roller coaster or something like that, or like the bottom of a hill, like the bottom of a mountain where you come back up, you know, the minimum point. So right down here, this point right here is your minimum. Okay, that's your minimum value. All right. Consequently, we also have what's called a maximum. Okay. And this is, you know, in a function, the y-coordinate, important that we note that this is a y-coordinate, okay? The y-coordinate of the highest point on the graph of the function or the largest value in the range. So again, I'm going to say this, that the max value, so the max is a y value, okay? And what we would also say is we would say it's the largest y value. Okay? Consequently, over here, the minimum value is the smallest y value. Okay? Smallest y value. So what we have here, over here, and I'm going to call this up here, this point up here, is the maximum. Okay? And one thing that I would like to note here is we get maximums and minimum values when the graph changes from increasing to decreasing or from decreasing to increasing. So if I come over here, you know, the graph here is increasing, okay, and then it's decreasing, and that point where that changes is a maximum, okay? And same thing down here. If we go from decreasing and we switch to increasing, that's a minimum value. Okay, and so that's one way we can check, because we'll have absolute, we'll have local, and we'll kind of talk about that, but that's the idea. And then the other thing that we need to talk about, a big thing here, is the axis of symmetry. So in a parabola, the line that passes through the vertex and is the line of reflection. So I'm going to draw a picture here, and this occurs at a maximum or minimum value. So at the maximum value, if I were to draw a line, you know, going down, straight down, okay, that is our axis of symmetry. Okay, and same thing here. You know, if we had a parabola that, say, opened up like this, and we drew a vertical line going up from the minimum value, then that is also going to be our axis of symmetry. Okay. So that's the idea there. So let's take a look at just a generic function here. And this is a function, f of x is equal to ax squared plus bx plus c. And so what I want to do is identify our minimum value here. So I'm going to put a point down here at 2, negative 2. So at 2, negative 2, okay, this is our minimum value. Okay, this is our minimum value. Okay, we also call this point a vertex. Okay, and a vertex is going to either give us a minimum or maximum value. Okay, and then consequently, what we get here is we get this value, this line of symmetry, okay, that goes through, and this line of symmetry, or axis of symmetry, is the line x is equal to 2. Okay, when I have the line x equals 2, that is a vertical line, okay, going through 2. All right, and I kind of want to show you guys how we get this, okay? What I have here is I have this, this function here, f of x is equal to ax squared plus bx plus c, and if I wanted to find the vertex, okay, which will give us our minimum or maximum value, then I would say that that value here, x, is equal to, let me rewrite that, x is equal to opposite b over 2a. Okay, and so where I get this b from is this value here, this b value there. Okay, it's that coefficient in front of the x. The value for a is the leading coefficient in front of the x squared. So if I identify those two numbers, then what we can do is we can evaluate the vertex. Now, this is for the x value of the vertex. Okay, this is for the x value. All right, and this will also give us our axis of symmetry. Okay. In order to find the y value, okay, to get the y value of the vertex's y value, then we would actually plug in the value of opposite b over 2a into our function. Okay, and I'll go over that here in a bit. But that's just the idea. Okay, so our vertex, okay, this will give us our max or min value. All right. Now, if I put them together, if I put the x and y value together, then the vertex is opposite b over 2a, comma, the function evaluated at opposite b over 2a. Okay, so kind of a lot of weird stuff that we're talking about, but that's the idea. All right, so what I want to do now is take a look at this question down here, and it says, gives us this function, okay, and it wants us to identify the coefficients, and it wants us to identify the axis of symmetry. Now, the one nice thing about this is that we actually do have a table of values here, but I kind of want to go through this and talk to you real quick about it. Remember that it's asking us for the coefficients. Coefficients is the number in front of the variable. And so when we have this, you know, we have our generic standard form, which is ax squared plus bx plus c, okay? And so our value for a, okay, is going to give me 2, okay? My value for b is going to give us -8. And then our constant c is going to be the value of +6, okay? So now it wants us to find the axis of symmetry. So remember what we need to do here is we need to find, for the axis of symmetry, I'm going to write this down here, axis of symmetry. We want to use x equals opposite b over 2 times a, okay? Now remember, okay, we've identified that the value for b is -8, and the value for a is +2. So if I come down here, I'm going to substitute these values in, and so I'm going to get opposite of -8, which is, so -8, all over 2 times a, which is 2. Okay, and so I evaluate that, and I come in here and I say, all right, well, I've got opposite of -8 is actually +8 over 2 times 2, which is 4, which gives me a value of 2. So the axis of symmetry is the line x equals 2. And that's all I need, okay? So if I take those values and I plug them into that little formula, that's what I get. So I'm just going to get that x is equal to 2, okay? Now let's go ahead and just graph these and kind of see if this all makes sense. So I'm going to graph the point 2, -2. So I'm going to graph these and plot them on the graph. So I got 2, -2, plot that point. And this appears to be where our vertex is. Okay, that's where our vertex is. And the reason why is because when I found my axis of symmetry, I got the value of x equals 2. So when x equals 2, if that's my axis of symmetry on a quadratic, then we automatically kind of know that that's where the vertex is going to be. All right, and then the other values were the points 1, 0. So this point here, 1, 0. And I'm going to plot a point there. And then the point 3, 0, plot a point there. And then I'm going to do the point 0, 6, which is up here. And then I'm going to do the point 4, 6, which is the point up here. And so if I draw this, it appears as though we have a parabola. And if I want to identify my axis of symmetry, it is the line x equals 2. Okay? And then that's our axis of symmetry. Is it? Yeah. Oh. Isn't that nice? So that's the idea. Okay, and you know, if we wanted to find, you know, and so here's the other thing that I want you to see, okay? Notice this value here says x, and this value says f of x equals 2x squared minus 8x plus 6, okay? This is your column for your x value. This is the column for your y value when you read that. Okay? So that's the idea. All right, let's continue on real quick, and I'm going to go through these real quick, and it says identify the properties of the given quadratic. So here it wants us to find the values for a, b, and c. So my value for a is going to be -3. My value for b is going to be 6. And then my value for c is going to be 17. Okay? It wants us to find the axis of symmetry. So remember, axis of symmetry is x is equal to opposite b over 2a. All right, so b was +6. So I'm going to come in here and write that I have -6 over 2 times a, which was -3. And so we plug all that in, and we're going to get -6 over -6. So we get an x value of 1. Okay, x is equal to 1. All right, and then it wants us to actually find the vertex. So if it wants me to find the vertex, then I need to take this value of x equals 1 and plug that into the function, and that's what's going to give us the y value. So our vertex, so that's going to be y is equal to, oh gosh, what's this function? Okay, so -3x squared, so -3, so let me do -3 times 1 squared plus 6 times 1 plus 17. And so then that's going to give us y is equal to -3 plus 6 plus 17. What is that, 20? Yep. So we get the value y is equal to 20. And so the vertex is the point 1, 20. Okay, this is our vertex. Okay, and then it says the vertex is at a, oh gosh, I don't even know what that says. I would say it's at a minimum, but we'll discuss that later. Okay. All right, let's take a look at the next one. Over here, okay, it doesn't give us anything. Okay, it just gives us this equation y equals ax squared plus c. So it doesn't give us, any value. But what do we know about b in this case? What's b equal to? If we're not given a b, b would have to be 0. Exactly. So on our axis of symmetry, remember, we've got y equals opposite b over 2a. And so if b is 0, or not y equals, that's x equals opposite b over 2a. So if we're looking for the axis of symmetry and we know b is 0, we're just going to plug that in. So we get x is equal to 0 over 2a. And so our axis of symmetry is just going to be 0. Okay? So x equals 0. Now if we want our vertex and we plug in 0 in for x, we get a times 0 squared plus c. So y is equal to a times 0, so a times 0 plus c. Well, some number times 0 is just going to give me 0. So we get a y value of c. So our vertex is the point, actually 0, c. Okay? Kind of tricky, but that's the idea. So when you don't have a value of b, like in this case, now we've got numbers here. All right? I would say y is equal to -3x squared minus 12. I know that my value for a is equal to -3. I don't have something x. I don't have a b value. Okay, b is the number in front of just an x. But because I don't have an x, I just know that b is equal to 0. And then c is equal to -12. So my axis of symmetry, again, we're going to use x equals opposite b over 2a. Okay, because b is 0, we're going to do x is equal to 0 over 2 times -3, which is just going to give us x equals 0. That's our axis of symmetry. All right, then our vertex, we're going to plug in 0 into that function, and we're going to get -3 times 0 squared minus 12. And so we get y, -3 times 0 is just going to give us 0, so we get 0 minus 12. So we just get that y is equal to -12. So our vertex is at the point 0, -12. And that's what we're looking for, okay? And what, hopefully you see a similarity here. Okay, you see that we have a b value of 0. Same thing here, and that we just had the point 0, for our vertex was the point 0c, whatever our constant was out here. And that same thing applies. We get 0, comma, negative 12, which is that value for c that we had. Okay. All right, next thing we need to talk about is the 0 of a function. This is very important, especially when you get to calculus, talking about zeros of functions. Okay, and so the first thing we have is a 0 is a value of x that makes f of x equal to 0. Okay, now that doesn't really make a whole lot of sense, but this is saying when you have f of x equals 0, that's like saying y equals 0. Okay, and when y equals 0, that's when you cross the x-axis. Okay, and so that's what we're kind of looking for. So a 0 of a function is where it crosses the x-axis. All right, or also an x-intercept of the function. So here, okay, on this one, you have 2 zeros. 2 zeros. We would also say that this quadratic has 2 solutions. Okay? Because we intersect the x-axis twice. On the next one, okay, we have 1 0. Okay, so we have, this graph actually just has 1 solution. Okay? And then this graph over here has no zeros. And we would say that this has no real solutions. We will talk about how to solve these types of equations when you have no zeros or no real solutions. But for right now, if you don't get a value, then don't really worry about it. Okay? So then over here, we've got that same graph that we were looking at, and we want to identify the zeros. So what we want to do is we want to say when is y equal to 0? And what we see is we have these values here, 1 0 and 3 0. So you can tell by the graph where your zeros are, okay, when your y values are 0. Or you can just look over at the graph and identify those points where it crosses the x-axis. And those are your zeros. Okay? We are concerned about that. That is a big thing with us. Okay? Especially when you move on to calc. Then it's really apparent. Okay? Okay, on this next one, it says a quadratic function has a line of symmetry at x equals negative 3.5 and a 0 at negative 9. And it says, what is the distance from the given 0 to the line of symmetry? So remember with symmetry, okay, it's equidistant from one side to the other. All right, and let's just kind of draw a quick little graph here to kind of see what we need to do. And so we have a line of symmetry at negative 3.5, so I'm going to put that value here, negative 3.5, and then a 0 at negative 9. Okay, so I'll call this negative 9. And so, who knows what's going on here, but let's just, I'm going to draw a line of symmetry here, and I'm just going to kind of quickly draw a little parabola here, and we'll just maybe call that a maximum value. But what it wants to know what is the distance from the given 0 to the line of symmetry. So what's the distance from here, this point from negative 9 to negative 3.5? Okay, and all you would do to find the distance between 2 points, and I like to do right minus left. I like to take this value on the right and subtract it on this value on the left. And so I do negative 3.5 minus negative 9. So negative 3.5 minus negative 9. So that's really just going to give us negative 3.5 plus 9, which, what is that, 5.5? 5.5? So a distance of 5.5. All right, and then it wants to know what is the other 0 of the quadratic function. And all that's going to be is a distance of 5.5 going this way. All right, so if I calculate a distance of 5.5 going in this direction, we want to figure out what this point is. Okay, what that x value is. I know this is 5.5. This needs to be 5.5. So I'm just going to take negative 3.5 and add 5 to that. So negative 3.5, I'm going to add 5.5 to that. And that's going to give me, what is that, 2? So a or an x value of 2, and that's what we want. So we would just say, what did the other 0 is, so the 0 is at, you could just say x equals 2, or you could say 2 comma 0. Same thing. Yeah, same thing. Okay. All right, so then, all right, it wants us, on this one, it wants us to kind of go over here and calculate these values for A, B, and C. Okay, so I'm going to plug in, I'm going to plug in -2 into the function, I'm going to plug in 0 into the function, and I'm going to plug in 2 into the function. Okay, and so let's go ahead and do that. So I'm going to do, to find A, I'm going to take f of -2. Okay, I'm going to take -2 and I'm going to plug that into the function and see what my y value is. So when I do that, I'm going to do negative quantity -2 squared plus -2 plus 6. You guys can get screwed up on your signs here, so be careful. This is going to be -2 squared is positive 4 plus -2 plus 6. So we get -4 minus 2 plus 6, which is actually just going to give us 0, right? So the value for A is 0. Okay, so I'm going to put that value up here, that this is a value of 0.
Didn't you say earlier that y can't be 0?
No, that's when we have a 0. Yeah, oh yeah, y can be whatever it is, whatever you want it to be.
Sorry, A. That was like one of the definitions.
No, these are, okay, good question. We've already, the value for A here, yeah, good question. The coefficient here is -1. Okay, this is just saying, okay, these are just variables. A, B, and C are y values of the function.
Oh, so we're just finding the y.
We're just finding the y values. Yeah, good question. Excellent question. Yeah. These are just values for y. Okay. Yeah, we already have the coefficient. So as long as this value right here isn't 0, then we're good. All right, so let's plug in 0 into the function. So I'm going to do f of 0. And that's going to be negative quantity 0 squared plus 0 plus 6. And if I just plug in 0 for all those values, everything is going to be 0. So the only thing that's left is going to be positive 6. Okay, so your value for B is, whoops, not B, is 6. Okay, dang it. All right, and so this value here is 6. All right, so then, all right, let's find f of 2. Methinks, okay. If I do f of 2, I'm going to get negative quantity 2 squared plus 2 plus 6. So we get negative, 2 squared is 4, okay, plus 2 plus 6. And so 2 plus 6 is 8, plus -4 is just going to give us a positive 4. All right, so when I plug in 2, we get a y value of 4. So I'm going to put that up here and say that this is C is equal to 4. So this value is 4. Now here's the thing, okay? What I want you guys to see is that, you know, we get a value of 0, 4, 6, 6, and then 4. And these values kind of repeat. And it wants to know what is the axis of symmetry. Now here's the thing. I kind of have the sneaking suspicion that my axis of symmetry is going to be in between 0 and 1, okay? You know, if you actually plot these points, and let's just kind of quickly do that, you know, here's -2, -1, 0, 1, and 2. -2 has a y value of 0. -1 has a y value of, say, 4. 0 has a value of 6. 1 has a value of 6. And then 2 has a value of 4. So you get this parabola that looks like this, all right, and you would have to say that the axis of symmetry is in between 0 and 1, okay? So I like to draw a picture to kind of show that, but let's just do it algebraically just to make sure. Now, based on what you said, you were like, hey, what's the value of A, B, and C? So I'm going to say that A is equal to -1, B is equal to 1, and C is equal to 6. So if I come over here and use that information from the parabola, from the function that we were given, okay, I know the axis of symmetry is x is equal to, opposite b over 2a, and so x is equal to -1 over 2 times -1, and that's just going to give me -1 over -2, which is just positive 1/2. So x is equal to 1/2. That's our axis of symmetry there. All right. So then, okay, we know the smaller 0 is at x equals -2. Okay? So the smaller 0 is x equals -2. All right, and we found that from the table. But then the larger 0, we're like, okay, well, what's the larger 0? Well, remember that our axis of symmetry, okay, this distance from -2 to 1 to 1/2, this is a value of 2.5, right? So then if we go 2.5 to the right, where's that going to give us? That's going to give us a value of 3, right? So this is -2, this is 1/2, okay? And these values are equidistant to the axis of symmetry. That's one of the properties of parabolas that's unique, okay? And so I know it's a little tricky, and I'm kind of doing some of this in my head, but the larger 0 is 3, is x is equal to 3, okay? All right, I'm going to do the last few of these, to kind of talk about, what we've got with these projectile motion problems. Remember the first day of school when I did that projectile motion problem? This is the idea. Okay, we're going to do this a lot. So, what I have here in a projectile motion problem, I have this, this function here. H of t is equal to -16t squared plus v sub 0 of t plus h sub 0. And so what I know, v of 0 is our initial velocity. H sub 0 is our initial height. Okay? And so here, and the maximum height reached is the same thing as the vertex. Okay? Now, I do want to tell you that our x-axis is measured in time, and our height is, or our y value is measured in height. Okay? And I think this is in feet. All right? And so on this one over here, it says, on this problem, it says, what is the maximum height of the object? So we're given this, this value here, okay, of -4.9 t squared plus 19.6 t. I think we've seen this one before. Okay, but if we want to find the maximum height, okay, it wants us to find the y value of our vertex. All right, so here's what I know, okay? I need to identify my coefficients. I need to identify my a, which is -4.9. I need to identify my b value, which is 19.6. Okay? And so what I know is that the x value of my vertex is equal to opposite b over 2a. All right, so if I wanted to find that, then that would be opposite 19.6 over 2 times -4.9. Okay, so that's going to give me x equals -19.6 over 2 times -4.9 is -9.8. And so -19.6 divided by -9.8 is actually x equals 2. Okay? And actually in this case it's t, so t is equal to 2. So now, if we wanted to find the y value of that, I would find h of 2. I'm going to plug into my function and plug it in for t and see what we get. So I'm going to get -4.9 times 2 squared plus 19.6 times 2. And then, all right, so this is just going to give me this part right here. -4.9 times 4 is going to give me -19.6. And then plus 19.6 times 2 is 39.2. And so if I take -19.6 plus 39.2, it's just going to give me positive 19.6. So the maximum height, Okay, so our max height is 19.6 meters. Okay? And again, you know, when we think about this, our value for t is time. Okay? And that's our x-axis. Our y-axis is height, and that's meters. Height in meters. Okay, so what it wants us to find, what is the maximum height, that's a y value. And you got to put that together. All right? That's the hard part about this. Okay? All right, the last one says the daily production cost for cost C for X units, okay? So a manufacturer of gas grills has daily production costs. So, and it gives us this production cost. So for ever the number of units, X, that they have, there's a certain cost involved. And so it says where X is the number of gas grills produced, how many units should be produced each day to yield a minimum cost? So a minimum, okay, remember that's where you have a vertex, okay? And so what I want to do is I want to calculate the vertex. All right, first thing I want to do is identify my A, my B, and my C. Now, here's where it gets weird. Is so the A value is always the value that's in front of the coefficient that's in front of the x squared. So this value here is 0.125. Okay, the value for B is always the coefficient in front of the x. So that's actually going to be -5. And then the value for C, which we really don't exactly need right now, is just the constant, just the single number, and that's just 400. So we do have to identify. It's not always going to be easy to read from left to right. We have to kind of know what those values are. So to find the vertex, the x value of the vertex, I'm going to do opposite B over 2A. So that's going to give me opposite -5 all over 2 times 0.125. So if I do that arithmetic, okay, then I'm going to do, so that's 5 over, what's 0.125 is just 0.25, right? So if you do 2 times 0.125 is just 0.25, okay? And so if you do 5 divided by 0.25 is 20, okay? Yeah, 5 divided by, that's like 5 divided by 1/4. Yeah. So then, here's the thing. Do we need to find the y value, or just need to stop at the x value? Remember, x is the number of units. Okay, x is units. And that's it. Okay, if it asked for the minimum cost, then we would plug 20 into that function and evaluate it. But because it's just asking for units, we just want 20. Okay, so 20 units. All right, that's all I got for this. Hope you enjoyed it.